Hi and welcome. So tonight we're going to be working more on our node system. Ever since I made it, there's now a big list that I compiled here about like nodes that need to be implemented. And this is yoinked straight off of Blender. I'm just looking at the different nodes it has and then just copying them to C-Ray. Just looking at how they work in the node editor and then just implementing them, or trying to. This is actually take two. I tried to do this once and I learned how not to do it. So tonight we're going to be working on the transparent Bsdf, which is a node that basically just is used for alpha blending. You can make an object completely transparent like I've shown here. So you can have the object there and then you can plug in the transparent Bsdf and then it'll just make it completely transparent in that spot. You can even attenuate it with the color here in Blender. We'll be able to do that as well. But yeah, I learned how not to do it. I went in a completely wrong direction. It just didn't work. I stopped the recording. So let's see if we can make this happen. So the way we're going to do this is we're going to create a new node. So we already have alpha blending. We did a video on that before. I forget which one it was, but we did one that actually implemented this for the first time. And in that video, we put that logic in get closest intersection. So this is the way we do it right now. When we fetch an intersection in the path trace function, path trace is the function that builds up the path that we trace, because it's a path tracer, right? Here we call get closest intersection, which, as the name would suggest, what do we call it? Yeah, there we go. As the name would suggest, it gets the closest intersection, right? So we pass in a light ray, the scene, and the sampler, and then it'll return us this big intersection struct that contains all the information we need about that intersection. So the way it works right now is the logic is kind of baked in to this function. So it's not really in the node system. It's kind of weird that we do this one thing in here and everything else in the shading code. So this change will get rid of this. We'll no longer do it this way, basically. We're going to make it a node instead, which is going to be much cleaner because we can actually attenuate it with textures just like all the other nodes. We can mix and match and do all sorts of cool stuff. So alpha is, by the way, completely different from glass. So if we actually make a glass node here, Blender's a good reference for this kind of stuff because I'm basically just copying it. So here we got glass. Let me make that white as well. You can see glass refracts, it reflects, and whereas the transparent is just nothing there. Instead, actually it's kind of colored, but yeah. So yeah, we're gonna do this logic but in a node. And full transparency, I did this once and it failed epically. So we're gonna try that again. So if you see me go really fast, that's why. So what we did before, we're gonna make a new file. Just kind of going through the motions as I did before. Transparent. And we're gonna make it very much like the other nodes. Let me make this a pragma once. Someone told me that it would be better to use the proper include guards instead of the pragma ones, but we're gonna steal the diffuse code here. Just plop it right in here and go from here. So this is kind of a simple example of a node. We're just gonna modify this to fit our needs. So transparent node in Blender, again, we're gonna cheat and look at this. It doesn't take anything, it takes a color optionally. Otherwise it defaults to white and then it returns a Bsdf that we can then mix and match. Another option that someone tried in the previous attempt was to pass in a Bsdf to this node and then the factor and then kind of use this as the mix shader, but that doesn't make sense because I realized you can just use it with the mix shader, so we're going to do that instead. So the way we're going to do this, first of all, let's make the interface. So transparent, right? This is not going to take anything. It's just going to take the node pool basically. So world, and yeah, there we go. New transparent. And another thing that failed in the previous attempt was I modified this struct to be sort of like this. So we don't need anything in here. We don't have any parameters. Just nothing is in here. Then the hash consing broke, which still not sure what. We basically returned null from here, I think. So that didn't work. But yeah, we'll figure that out. New transparent. Then we have to sample it. Yep, this interface is standard. It's in here. So the base Bsdf has the sample function pointer that we set down here. Sample. These are our static functions. They should be static. In the case of diffuse, it's not static because we use the diffuse logic in the plastic shader, which is kind of ugly. But yeah, so this, clean this up a bit. Let's see, compare, sample. Yeah. Okay, so then, let's see. Actually, yeah, it's sort of what Blender does. So the hash consing broke because we don't have anything inside here. Normally we use the kind of contents of this. We don't use the base Bsdf for comparisons or hashing. We use the contents. So I didn't have anything in there. It didn't work. So we're just going to stick the color right in here, just as Blender does. So it'll be like, kind of like that. So that should work. Let's see here. Where am I? Like this one, this one, this one, this one. What else? This one. And then for the actual sample, it's going to be really simple. We're literally just going to return the scatter direction is just going to be whatever we pass in. So the way the this one works is, so okay, we find, okay, if we have the alpha channel in the material, well, we get the alpha value regardless, and then if it's like not 1, we will basically just start again from the hit point. So the ray hits the surface. Normally we would bounce off or refract or reflect or something like that. In this case, we just continue straight through without doing anything to the ray. So we're gonna model it here and here. So the scatter direction is it's gonna just be the incident ray direction. So record incident dot direction, and the color we're gonna just, and this again I found this out in the previous attempt, that we want to modulate or attenuate the ray with white color, so we don't do anything to it. This is so simple that we can actually just do sort of something like this. And we don't use any of these parameters, so we're just going to void Bsdf. We don't need sampler. We do use the record, don't we? There we go. Right, and actually, yeah, we want to attenuate with the color, right? We don't want to use white color, so we're going to use the Bsdf. After all, so struct. Maybe this is a bit of a boring video since I'm really just typing out code that I kind of figured out once before, but we'll see. So this will be this Bsdf. Then it's gonna be like this color eval this color record. So this is the way we evaluate this texture node. This should really be called like a color node, to be honest. Got my new tea mug. That's good. think we'll rename this actually. Maybe we'll do that in this video. And so this will actually take the color. So struct texture node color. We'll do that as well. So like that. And then we'll pass this in. If you're wondering about this macro, what it does is normally we would just construct it in here, return it, and allocate it on the node pool. But hash cons, what it does is it'll create the node, and then it'll check in a hash table. It hashes it with this function. It'll check in a hash table if we already created one identical to it. And if we did, it'll just return a pointer to that one instead of making it again like a duplicate. So this way we can guarantee that each node in our graph is going to be unique. So we can do these kind of simple pointer comparisons between them. It's a really neat technique. I didn't come up with it. It was pointed out by a friend with some help. I think I already mentioned this before, but if you didn't see that, that's why this is. If you want to see it, it's just there's a lot of code to type to make it happen. So I'm using this useful little macro here. It'll even print out what it's doing, so we can use that for debugging. Okay, so got this. Does this look all right? Direction, eval. Yeah, that looks reasonable. We gotta include it in here so the other guys can see this. Transparent. So the way it works right now, I have this little test scene where the sphere here in the scene is transparent. Right now it's using the old way. So if we look in the code, it gets the alpha channel from the material, or if it has a UV map, I'll use that. So if we look at this file, you can see that I've set the alpha here to 0.25. This is the old way of doing material properties. So it fetches them from the wavefront file, and then you can override them here, sort of. And the way it works right now is that you can give any primitive or mesh this material object here, and that'll basically override most of this stuff. So it'll ignore all this stuff. That'll just be like a hierarchical description of the node graph here. I'll show that more in just a bit when we do the actual parsing. But right now it took the color value from here, or the alpha value, and then we got this image. This one. So this is our reference. We want to get to this. So we're gonna alpha before PNG. So this is our before we want to get back to. I'm gonna stash that. And then we're already here. You get rid of this one. I'm no longer gonna do that. This looks a bit derpy now. We'll have to fix that. Yeah, so the way we can do this is make the parser right away, so we can do all this like in this material thing, but I'm just gonna disable that override, like with the DE. It's not gonna find it now. What do we get if we do this? Get some interesting image. I guess it's just mirror finish. I mean, at this point the color is like uninitialized, so I guess that's what it comes out as. But regardless, we're gonna override it. So the old way, the old system that parses the materials from the matillib files uses this assign Bsdf function, which just, yeah, you basically saw it here. You specify the Bsdf here, and based on that, it'll select one of these. No mixing or matching or anything like that as the new system has. So this is gonna go away once we've moved away from it. But for right now, it's useful for overriding stuff. So we can actually just stick it in here. And construct our node graph straight up here. So before we do the actual parsing, because we're going to have to write that up in just a bit. So the way this works now, similar to Blender, we're gonna make a mix shader. New mix. And we pass in the world because we need to. The world has the memory pool for all the allocations, and it also has the hash table it looks up against to do the hash consing to remove duplicates. So that's why we pass all that stuff in. So the first one is going to be diffuse, just like before, right? New diffuse. And for this, we're going to load up the texture. This is temporary, of course. What was it? Input earth. Right? And then the second one is going to be new transparent world. New constant texture world. And we're going to just pass in white color for now. And then the factor is going to be the actual alpha channel. And what I noticed on the previous run was that the factor we provide for the mix shader is kind of evaluated weirdly. What it does is it takes the factor, color, turns it into grayscale, and then takes the red channel. So which means that we're gonna have to do like new constant texture world and then sharp color and put the values in all the fields. Right, something like that. What happened here? New diffuse. Oh, we're gonna have to make it new image texture. Building this stuff out in the code is a bit derpy, but it's only for testing. So now we have a mix shader that has a diffuse and a transparent, and it's 0.25 solid, basically. Yeah. See if that does anything. And the old code is gone, right? I think so. Yeah, we removed it. Oh. Added new files. Okay. That's cool. It works now. That was quick. How many minutes is this? 17 minutes. I would not have been able to do it this fast if it was like my first time. Yeah, we got to this point basically, and then it got weird. Let's look at this image. Rendered. Do we have the other one stashed away? Yeah, we do. Before. So let's compare these guys. Oh, it's actually different. Before it's like that. Now it's like that. That's not good. Okay, we'll figure out what's going on with that. Okay. What happens if we set it to point like 0? Like completely transparent, like nothing at all. If it links. There we go. Okay, so that looks correct. Okay. Yeah, well, obviously it goes away. Huh. Why would it look different? What do we do differently? I mean, we attenuate it here instead of... What if we do... like completely solid? Like this. Doesn't look correct. It's too bright. Wait, it shouldn't be too bright though, because now it's fully diffused. Let me go back to the old way. by commenting out this crap. Then is get closest. Put this back and then change this guy to 1.0f. Use that. Oh, wait. So we gotta. Oh, it's metal. Diffuse. Oh, and the color is okay. Which, let me see. This is sphere. Oh, we don't actually do texture mapping for. No, we can do this. Yeah, we can just bring back this guy. The old system doesn't even support texture mapping for spheres. That's why I was confused, but we can bring this. This is dark. That is weird. Which one is correct, though? This is the eternal question. Are we not transforming the... We should be transforming it from sRGB, but yeah, transform true. What? Did that just change? What happened there? Right, it's yeah, of course it's dark. Yeah. Okay. Okay, let's look at what is different here. If we comment out the code that does this, or just yoink it, what happens now? It's dark. This is what we would expect. Let's open that texture. Yeah, it's darker than it was supposed to be. Yeah, so this is more correct. I don't know if I have the rights to that image, but whatever. Okay, so in this case, we would go through assign Bsdf, and then it would load. How would that happen? In this case, it would use the parse node. Okay, so the way we parse the nodes, node graph is parse node, gets the node here. Let me open this up. So it gets this node here. This is what gets passed in. And then we just recursively parse this. So diffuse, parse texture node. Then it gets the color. In this case, color is an object. So it'll parse the texture node. And then it knows that it's an object, right? This one. Then it will get the options. Yeah. We don't want to lerp it or whatever. This doesn't matter. This is kind of derpy because it can either be, you know, this one or it can be this one. So we check that it's not this one and it's this one. Then it gets the path and then the options. Oh, that's wrong. No, wait, no, it is. So it's enabled by default. And then we flip that back off if we set false to transform, which is not the case. Why would it be different? What if we switch to the new system? This is all kinds of derpy. So let's make sure this one works. Is it the attenuation? Okay. Did that wait, what is happening here? We gotta. So is this one? Yeah, we gotta disable that one to get to this assign Bsdf. Okay, so there we go. Now it's wrong. What happens if we attenuate it with... So the attenuation is white color, red color. That should not come through at this point. If it does, it's wrong. Okay, so it's not that. Then what is it? Oh, okay. So look at this. We don't pass the options in. Derp. Because we did the inline. So when we create the image texture node, we passing this options bit field, which tells it to, in this case, we didn't do the sRGB transform in this case, in the debug case, because we didn't pass that in. If we do this now, it's going to work. We're going to make this white color before I forget. There we go. Okay, back. Cool. So now if we do 25F, at least we're learning something, which is check your debug code. Okay. I'm showing my cool mug. Serenity OS mug. I love this thing. Okay. Okay, that works. So let's compare that to the old one. Mildly different, and now this is a case where oh, we're not lerping either. Let's change that as well. No, lerp. What are the options again? No, bilinear, okay. No, but that would be... It defaults to enabling that, so it's the same as before. This is one of those subtle things, like, is this more correct than the previous one? I don't know. I'm gonna file this into the category of let's worry about this later, since it's almost kind of working. Yeah, let's do that. Correctness is something we can verify later. So that kind of works. Did we want to do something about this? Let's try and attenuate it with like red color. Should be like reddish, hopefully. Sure enough, let's make it completely transparent. I'm getting tired of this copy pasting of this. So next up, we should figure out how to parse this thing. Should not be too hard. We're just gonna add the parsing logic. There we go. Okay, cool. This works kind of like it does in Blender. So let's do like diffuse Bsdf here, and this is like just a white surface. Let's do the red. Then we'll do the transparent. Then, yeah, you can sort of see similar kind of deal, right? Just a void of red. Cool. Unless we set the thing to like, you know, back to what it was. So cool. We should, first of all, this is fragile. If we don't get a color in, we should default to white. So if we get a color, we set the color. Otherwise, on constant texture, white color. So we can just pass in null. We do this for all the nodes at the moment. You can pass in null and then get like somewhat sane defaults, usually. Okay. Then we gotta do the parsing, so let's get rid of this guy. Parse node. We're just gonna add on to here. String equals type value string. Transparent. Then the color. How do we want to represent this? So let's figure this out. So the way we want to do this is, first of all, type is going to be mix, and then the A Bsdf is going to look like this. Oops. Diffuse. And then the color is going to be color. Like that. And then the B shader will be another object. Type. Transparent. And then, let me think. Yeah, this takes a color. I'm just gonna set it to white. Actually, wait, let me see. Parse color. So if we find the color and the color is gonna be null, we pass in null, it's gonna return null. Then it's gonna, yeah, we're gonna not do this. So it's gonna be just a transparent node. And then the factor that mixes them, well, let's mix it up. Let's do type diffuse and wait, hold on. The factor is a texture. It's gonna be type checkerboard. Something like 250. Something to mix it up. Is that valid JSON? That should be valid JSON. It's gonna mess up because we haven't written the parsing logic, but that's how we want it to be structured, I think. Yeah, there we go, okay. Yeah. Okay. It doesn't actually warn about it, but that's fine for now. Okay. Oh, it was disabled, no wonder. Material. Now it should give you a warning. Yeah, it sets it to like obnoxious. Yeah. So it could figure out one of the nodes. This is the way it works. So if it can figure out a texture node, it'll return you that. But otherwise, it'll return this unknown texture. It couldn't figure it out. It's gonna print the warning. Failed to parse. Doesn't know what this is. Set it to obnoxious pink material, which is a obnoxious pink material. Unknown texture node is definitely not that. It's a black color. But then how was it actually? Oh, I guess. Oh, it's just the node. Okay, so it can figure out the node here. Then it'll return a warning Bsdf, which is a mix of two diffuses with a checkerboard, which is what you see in the image. So let's fix that. So first of all, return new transparent w color parse texture node w color. That should do it. Maybe it'll do it. A fairly quick video, but I've already kind of done the research, I guess. That looks good. Let's mix them with a constant color and see what that looks like. Set it to 0.25f and compare it. So this is going to be, the factor is just going to be a color node, right? So we can do, I think, and I might be wrong here, but I can do this. Am I wrong? I'm not wrong. Okay, cool. 0.25f. We'll compare this. I put too much sugar in that. Way too much sugar. Okay, let's figure this out. So before and after, make this the same size. This is kind of how I compare these images. Or not. Like this. Okay, so before and after. Now they're identical. And I forgot what could affect that, but that's better, I guess. They're not different. So two completely different ways of doing it, but now this is actually modular. You can actually do this in your node graphs and mix it and match and do all sorts of cool stuff. That was fairly easy, but obviously, again, I did this once before. So I guess we should tidy this up. We have this alpha test scene. We might want to commit that. Just look if there's like anything obnoxious. There's a bunch of other experiments I can share this. I've been messing around with the HDR scene. Bunch of weird stuff going on in here, but maybe that's for the next video. Yeah, so get let's see if there's anything weird here. Yeah, get rid of the texture loader. Don't like that. What else? Transparent. Yeah, that looks good. Defaults to white color. That's good. Hashing looks logical. Now that makes me think, actually. Is that correct? Let's check that. Is the size of operation here correct? Oh, that's awkward. That it's not a member function. LLDB, this is C. You messed that up. Okay. I guess well, C++ people will tell me that you shouldn't call it this, because then C++ compilers will fail to compile it, but okay, maybe will work. LLDB is a bit derpy. Sometimes it does assumptions that aren't valid. Size of this color. No, it was thing. There you go, 8. What if we dereference that? Ooh, wait. Okay. Pass in the address of that. We're just gonna pass in that. This might not be right, actually. What do we do elsewhere? Diffuse. Similar deal. Maybe these are all messed up? Wait. We hash the bytes. Bytes and size. Okay. Data and then... I think we are not hashing these correctly. I'm gonna fix that in a different commit outside the video, but I don't think this is correct. I don't think that's correct. I'll fix that after the video, but yeah. Transparent. Do I find anything else obnoxious in here? Nothing much. I think it works. Obviously, all the existing scenes don't use this yet, but the idea is I'm just gonna work on this once I have it all figured out, like the interface for the kind of the node graph in the JSON. Then I'll kind of move everything over to that new system. But yeah, this looks pretty good. This was from the before attempt. Yeah, okay. Commit that. Do 5. Yes, please. Patch 5. Yes, that looks good. 5. Yep. 5. Oh, right. Does that look good? See, so this function now looks a bit derpy since we removed all the logic. Because then, if we did the thing where we continued on, then we would modify the intersection struct rate. So in this case, I guess we could, so if this doesn't happen, return it. Otherwise, we return the same thing. But this gets modified either way. So we can basically ignore the return value. Because this returns if we hit yeah, it has hit. So if we return false, close this intersection. If we return false, that doesn't matter in this case because either way we check the instance index. It gets the set. It gets set to -1 if we don't hit anything, and then we get the background. So yeah, we can ignore the return value. Maybe we could check and modify the API a bit so it doesn't return anything, because now we're just ignoring the thing. But that's fine for now. We don't need the sampler in here either. Okay, so let's remove that. Yoink, made the code a lot cleaner actually. Don't need to pass the sampler in here, because now it's in the nodes. Same deal here. Anything else? This looks a lot cleaner. Is there anything else we could do to this? Insect, yeah, we'll just initialize it to whatever you want. Insect polygon, yeah. Do we actually use that? What do we use that? Let's comment that out. Do we use that? We do use that. Record. Okay, set the polygon. Set the polygon. Text map mesh. Yeah, it's used. It is used. Perhaps not the best design of all time, but yeah, it's used at least. Just thought to check that out. Okay, I think this is fine. Let's commit this. So patch 6. Wait, what? Use of uninitialized value in sprintf. That's interesting actually. You see how get like messes up there? That's weird. Let me screenshot that for later. Let's just restart this. Get out I patch. Okay, now it works. Don't know what that was all about. I'll ignore that. Yes, please. Does this actually work? We should probably compile this and make sure it still works before we check it into the branch. If you're following along on GitHub, as I mentioned here, the improvements are right now on this branch. So if you want to check that out and see what you can do or whatever. So there you go. Okay, it works. Come on, commit this. 5 scene loader. Yeah, very simple changes to the parsing actually. I'm pretty happy with how that came out. It's very simple. No, we don't want to patch. No, don't do that. Anything else? Oh, the Xcode project. Yeah. Yes. 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 Do we have anything here? Nah. What about UE sphere? No, let's add the alpha test thing. What was it? Alpha node. Oh, but then we need to modify the earth PNG to not be that, because that's not included in the repository. Let's see if that works. There we go. Okay, that's good. Patch. Alpha node. I'm still getting used to this interactive staging thing. It's pretty nice. I just gotta get used to the interface a bit. Yeah, we went through this. Nah. Okay, I think that's good. Cool. Sprite Bsdf node. This moves. Will be much more fun. It'll be. How do I word this? Can be used more flexibly. That's not a word. We can't use that. So it can be used in more creative ways. Yeah, okay. That's good. Cool. That's the video for tonight. It is pretty short, 46 minutes. Again, take 2. What are you gonna do? Go buy one of these mugs. Andreas Kling is selling these cool Serenity OS mugs. And if you haven't seen his programming videos, go check those out as well. He's really, really good. So anyway, that's it for tonight. Thank you very much for watching if you got this far. And yeah, goodbye.